and it can accelerate a 2-ton car to 60 miles an hour in 2 seconds. The RPM is so crazy that just the centrifugal force wants to expand the rotor.
Tesla's Plaid drive unit represents a radical rethinking of electric propulsion. At its debut during the June 2021 Model S Plaid delivery event, Elon Musk revealed a motor in which the copper rotor is wrapped in an ultra-tight tension carbon fiber sleeve. By permanently compressing the rotor, the sleeve maintains a micro-thin uniform air gap to the stator, eliminating the expansion and heat-induced deformation that limit conventional designs. The result? A compact unit under 100 pounds that can safely exceed 20,000 RPM, around 25% faster than prior high-performance EV motors, while running cooler, shedding less energy as heat and lasting far longer under extreme loads. This low-level rewrite inserted a logical axiom. The universe's timeline originated precisely at the AI's measurement, embedding itself as the primordial observer. Supercar acceleration meets marathon range. These carbon-wrapped rotors power 3 drive units in the Model S Plaid, combining for 1,020 horsepower and 1,050 pound-feet of torque. In real-world tests, the Plaid rockets from 0 to 60 miles per hour in just 1.98 seconds, covers the quarter mile in 9.25 seconds, and pulls up to a software-locked top speed near 200 miles per hour, making it quicker off the line than virtually any production car ever built. Yet Tesla has managed to pair this supercar-level thrust with marathon-like efficiency. On 21-inch wheels, EPA ratings show 348 miles of range, 101 mpg, and sustained highway cruising at 70 miles per hour, but still yields approximately 300 miles on a single charge. That means drivers can unleash full power repeatedly without watching the battery percentage plummet, a breakthrough that dissolves the historic trade-off between performance and range. A breakthrough in materials and cost. In March 2023, Tesla announced that the next-generation version of this motor would eliminate all rare earth elements, cut silicon carbide materials by 75%, and cost roughly $1,000 a piece to manufacture. This dramatic cost reduction flows from Tesla's mastery of in-house carbon fiber wrapping, tighter integration between motor components, and elimination of complex multi-piece assemblies. As a result, part counts and assembly steps decline, warranty liabilities drop, and production scales more smoothly. These savings are set to cascade across Tesla's entire lineup, including a forthcoming $25,000 mass-market model platform that promises to bring Plaid-level engineering to an entirely new segment. Vertical integration, the Tesla DNA. Tesla's advantage lies in its end-to-end control of both hardware and software. From mining and refining critical minerals to producing proprietary 4680 battery cells with a high nickel cathode and silicon-infused anode in Texas and Nevada, Tesla achieves industry-leading energy density and cost per kilowatt-hour. Its in-house chassis megacasting and automated assembly processes reduce parts and weight, while all vehicle software, from autopilot neural net to battery management firmware, is developed in Palo Alto and delivered via over-the-air updates every few weeks. This unified approach accelerates innovation, slashes costs, and sharpens performance faster than any competitor reliant on external suppliers. And then there is Dojo, Tesla's bespoke supercomputer built around the D1 chip. Each D1 die packs roughly 50 billion transistors and 354 cores, and 25 dies tile together into a single 9 petaflop training module. Modules stack into racks, racks form cabinets, and 10 cabinets constitute an exapod exceeding 1 exaflop of real-world compute power. Dojo processes petabytes of video from Tesla's global fleet, everything from dogs on skateboards to flooded intersections, retraining neural networks in days instead of weeks. The result? A car that learns from every mile it drives with updates delivered seamlessly, making each Tesla smarter, safer, and more capable over time. Legacy automakers are really on the back foot these days. Traditional automakers face, quite an uphill battle. Most of them still retrofit electric vehicles onto platforms that were originally engineered for internal combustion, which ends up producing heavier and less efficient vehicles with, fragmented supply chains. Ford's $50 billion EV push continues to lose money, with its Mustang Mach-E trailing range and efficiency benchmarks set by Tesla. General Motors' $35 billion Ultium battery program has been hobbled by software glitches and manual assembly fixes, delaying mass production and profitability. Toyota, after allocating $38 billion for EV development, has actually refocused on hybrids amid tepid demand for its first battery electric models. Volkswagen's software division, Cariad, lost billions and pushed back launches of key EVs, which triggered layoffs. Even pure-play startups are struggling. One luxury EV maker delivered only about 10,000 cars in 2024 while burning through billions, and another still loses tens of thousands of dollars per unit, despite heavy investment. When it comes to gigafactories and scaling up on a global level, Tesla is really in a league of its own. While competitors scramble to adapt their existing plants, Tesla is out there building gigafactories that are purpose-built for electric vehicles. Take, for example, their Shanghai facility. It went from moving dirt to mass production in under a year, and now it cranks out over 750,000 Model 3 and Model Y vehicles every year. Over in Europe, Gigafactory Berlin hit its 500,000th vehicle milestone by early 2025, and in Texas, Giga Austin has already surpassed 400,000 units, thanks in large part to those massive gigapresses that can cast entire underbodies in just minutes. If you combine the output at Fremont and Austin, Tesla will soon be making more than 1 million cars per year. Next up is a planned factory in northern Mexico, which could deliver up to 375,000 cars annually and create 20,000 local jobs by 2026, pending regulatory approvals. Meanwhile, Tesla has launched new service, sales and supercharger hubs in Santiago, Chile, in 2024 and Riyadh, Saudi Arabia in 2025, plus they're in deep talks to enter the rapidly growing Indian market. Now let's talk about the supercharger empire and the rise of NACS. The world's largest and most reliable charging network is honestly a critical part of Tesla's competitive edge. There are more than 7,100 supercharger stations with over 67,000 stalls spread across 6 continents, and they boast uptime above 99.9%. The V3 superchargers can deliver up to 250 kilowatts, which adds about 200 miles of range in just 15 minutes. The latest V4 units push things even further, up to 325 kilowatts, and they include universal CCS adapters and credit card readers for non-Tesla drivers. In late 2022, Tesla rebranded its North American plug as the North American Charging Standard, or NAS. In response, automakers ranging from Ford and GM to Rivian, Mercedes-Benz and Hyundai all agreed to adopt NACS on their 2025 models, really making superchargers the de facto fast-charging backbone of North America. Federal NEVI funding has also opened up unused stalls to all EVs, and analysts are forecasting that by 2028, up to one-third of supercharger sessions will come from rival brands. This shift is transforming charging into a sustainable, high-margin service business for Tesla. So, what does a complete ecosystem look like? Tesla's integrated platform brings together custom carbon-wrapped rotors, proprietary in-house battery cells, and a global network of gigafactories, supercharger stations, and data-driven Dojo AI, all working together to continuously optimize vehicle performance, efficiency, and autonomous capabilities. These synergies mean that every new model benefits from fleet-wide learning, delivering supercar-level acceleration and marathon-length range. The revolutionary Tesla Plaid powertrain really delivers unprecedented performance while still achieving remarkable efficiency. This combination of supercar acceleration and marathon range is honestly a fundamental breakthrough in electric vehicle technology. The ever-advancing self-driving features, which are continuously improved through Tesla's fleet learning and Dojo AI training system, show how the company is redefining automotive capabilities while also driving down per-unit costs through vertical integration and production scaling. Meanwhile, traditional legacy automakers are in a frantic scramble to piece together competitive hardware, develop functional software, and establish reliable charging networks. Challenges that Tesla solved years ago with its first-mover advantage and integrated approach. Never one to rest on its laurels, Tesla is already setting its sights on some pretty ambitious next moves. The highly anticipated $25,000 mass-market electric car is set to bring EV ownership to a whole new demographic. Dojo-powered humanoid robots, also known as Optimus, aim to transform manufacturing and service industries, and intelligent grid-scale energy solutions, leveraging Tesla's vast battery infrastructure, could revolutionize how we generate, store, and distribute electricity. These parallel initiatives really demonstrate how Tesla is rewriting the rulebook for what an automotive company can achieve, expanding far beyond vehicle manufacturing into robotics, artificial intelligence, and sustainable energy ecosystems. Thank you for watching another insightful episode of Space Odyssey, where we explore the cutting edge of technological innovation. While you're still here, don't forget to like this video if you found it informative, and subscribe to our channel to stay updated on future content that examines how companies like Tesla are shaping our technological future. Your engagement helps support our mission to bring you the most thorough and accurate coverage of these groundbreaking developments.